Okay, YouTube electronic aficionados. I have a question. I was intending on doing a review on this Ryobi lamp, which turns out I really like, and I'll do that review later. But along the way, I was like, "Fuck it," I got this big old battery. I should, I should get some wireless control of this thing, right? Of course. And something just fell. So I did that, and I have basically this thing now, so I can. Well, first off, I guess a short throw of this button. Oh, let me plug the battery in. Let me plug the dangerous battery in. Try not to do this backwards. I just know I'm gonna. Okay, so we're all plugged up here. A long press of the normal button just shorts these terminals and it turns it on. If you press it again, it toggles through the different lights. And if you do a long press, it'll just turn it off. So essentially, I coded that so that we send in, it's listening on this thing, and it can toggle on, or you can just use that to toggle through the states. Or if you want to give it an explicit off, you can just send it to 0 and we do one long press and that turns it off. And I don't even know if I did that right. I mean, I just I just grabbed I think this is a something 7000. It's basically just a really little MOSFET as far as I know. So I use that to protect me against the pack voltage because I'm running this 3.3 volt dude, and I needed to switch this high voltage, which on this switch, which is what I'm shorting, so I'm just in parallel with this switch, it reads 18 volts, and I'm sure once it's on,
There is a reminder for work.
Okay, Google, shut up. I also integrated Okay Google onto my headphone. Hi Google. Where the fuck was I before I was so rudely interrupted? Oh, so there was 18 volts across the switch. Once it's on, I see 3.3 volts here. So anyway, I used the MOSFET to protect this dude because I wasn't really sure about that. And then this whole circuit isn't pulling any power until you short it, right? So at first my thinking was that, oh, I'll just pull off wherever the 3.3 volt regulator is on this thing to power this thing. But this guy doesn't get any power until you power it up, or it's an unusable amount of power, or I haven't probed enough to really find it. And it's possible I did something stupid there, so maybe a quick look at this is worthwhile. Those are all of the active devices. I didn't see an actual 3.3 volt regulator. This, I'm pretty sure that's a MOSFET. That's a MOSFET. And there's the rest of those dudes. On the back, this chip also has a dimming function that isn't in use, so I thought that was cool. Let me unplug the battery so I don't electrocute my whole deal here. And then on the back, there was a 5 volt regulator. Yeah, that guy, he's kind of running the show. I don't actually know where I was getting 3.3 volts, if I'm honest. And I'm sure maybe if I spent a little more time decoding this, you know, figuring out how this fucking shit works, but anyway, I didn't reverse engineer this whole thing, and I don't even know that I'm capable, but here's my problem set. This is what I just want to talk this through, because I mean, I think this just might be a lost cause. I'm trying to get shots of everything. So my thought pattern was, I got this big old battery, I'll just leach 3.3 volts. It looked like there must be a regulator on there. In the end, I didn't actually see one. So now I feel like that's lies. I saw that 5-volt regulator. I can't tell what that second MOSFET is next to the JS31. And so anyway, I've punted, and I'm sort of like, okay, I should just use pack voltage. So use pack voltage and just leach off that pack, and it's no big deal. However, when I started to think about it, you know, at first I just thought, oh, I could just use this regulator that I already have, which is a big old, you know, worst case scenario, use this big old inefficient regulator. But it actually peaks out at 15 volts, and I have 18 volt pack voltage. So then I was like, oh, maybe I could use a resistor divider, voltage divider. There you go. Which I haven't done a ton of, but once I started to think about it, it actually seemed worse. And here's kind of my thought. Like I guess I never really thought of this before. Yeah, so here's our basic resistor divider thing, and some of the discoveries I made along the way is, okay, well, obviously if your values here are too small, then essentially you're just shorting, you know, you're going to get current flowing here. So you want R1 and R2 to be big enough, right? Where you're not just shorting your pack and just, you know, burning up resistors. But then you need enough current to be able to power your device, right? So R1 actually becomes important to supplying enough current to run your Hungry ESP8266. So based on that current, that is going to determine that first resistor, which in essence defines what R2 is going to be, you know, roughly. So like some of the numbers basically, yeah, so here's some of the numbers that I sort of came up with. So with the basic voltage divider, and I'm just using this calculator, you know, 1400 seemed like a good one for R1, and that is because it is going to give me a flow of what? Not much. Not much current, but excuse me, what have I done here? Yeah, that's how much current I can get, right? And we're talking about current to supply the ESP8266. And here I'm pushing a quarter watt. So like that's kind of my typical resistor. You know, that's all it's going to be able to dissipate anyway, right? So, and then overall, the entire system from 18 volts to ground is just going to be throwing away 800 or, 8 milliamps. It's just going to be throwing away a tenth of a watt. Like, is that right? And this is all to get me to roughly 5 volts, right? I'm still going to have a regulator because I need regulated output. So, I guess my question is, this all just seems really, really wasteful, and I know the whole project is wasteful, but what do you typically do in this scenario? And am I thinking about this right? Like, I've never used voltage dividers to actually supply power for something, but my 3.3 volt regulator can't use 18 volts, So I guess the only other alternatives I have is to drop in like a switched, a switch regulator, which this thing seems like it'll be just as wasteful. And then what else did I think? I was actually wondering if an op amp could be used, and if that might be more efficient. But I guess what I'm saying is, yeah, I'm just a green newbie. I don't really have any experience designing this kind of power, and I'm just curious what others would do. If I've missed something, or if the efficiencies, of losing power through this flow are acceptable, or like, what would y'all do? What would you guys do? And then, yeah, I have other questions too, but this is the one that cropped up for this stupid this stupid electrical thing. Yeah. Okay, so now I'm rambling, so that's all I really have to say about that. And it's funny that I'm getting caught up with basic Ohm's law and basic like really basic shit. I don't fucking know. I just never really thought about it before. But I obviously don't know how to efficiently get power, or to efficiently step it down. And I think I'm just gonna punt on this whole project because I feel like probably the overhead of the power system is going to use as much as the damn wireless system, even though these dudes are pretty hungry anyway. But yeah, what would y'all do? That is the big question that I would love some help with, and I apologize for my ignorance. Yeah, so just so I'm not crazy, this regulator, which I didn't look up the pinout, but oh, you can't see what I'm probing. Look, I'm just looking for free advice here because I don't have any friends. All right. Yeah, so our little regulator, I don't think he comes to life until after the switch has actually been put on. Yeah, I'm terrified I'm just going to short something. I should actually have this hooked up to my supply. So turn that on, and then yeah, he's getting 8 volts, Which smells to me like there's a divider in there. Yeah, and there's our 5 volts output. So who else comes to life here? He's getting 5 volts. Yep. Yep. So it would have been much more convenient if there was a place I could steal something other than, you know. But I guess it makes sense that somebody designed this light so that it's not drawing a bunch of power. I haven't measured the actual power here. You know, however microvolts are flowing or whatever. I don't want to snip these wires, but it's nothing, and that makes sense. So yeah, do I just, you know, say fuck it and don't do this stupid little? Yeah, I mean, it just seems like such a waste to have this 4 amp hour battery doing nothing most all the time, especially when I have like others charged up right behind it. So like, you know, and I guess my thought was that maybe, you know, if the power goes out or something, I could just turn this light on as an emergency light, or, you know, maybe I'll install some other switches in here to work other little things, like when I'm running out to the garage or whatever. I don't know. It's stupid, but yeah, if anybody has any thoughts on my little power conundrum, I mean, I could certainly make it work. I'm just looking for somebody's experience on what the proper approach is.